The law of exponents is a set of rules for simplifying expressions that governs the combination of exponents, or powers. Okay, and recall that when you have the nth root, that is written like so. Why is it blue? Let's make it white. So the nth root would be written as so. You would put the number at the top of this little roof on the outside of the square root symbol, or the radical symbol, to be true. So the square root is automatically asking for one number, so that you multiply twice. That will get you a, the radicand, or the number inside the radical symbol. For a square root, you don't usually write a 2 there, because that's understood by default. But if you want to ask for a number that you multiply 3 times to get the number inside the radical symbol, then you would write the 3 at the top, right? So an example could be, what is the cubed root of 8? Well, you know 2 times 2 is 4. 2 times 4 is 8, so that would be 2. You're multiplying 2 with itself 3 times. All right, so the law of exponents is the following. Let's just say law of exponents. Okay, so you would say, well, if m and n are integers, then you'd have the following exponent. If you have x to the power of n, then you're going to multiply x with itself n times. N times. And if you have x to the power of 0, well, you're not multiplying x with itself any number of times. And since you're using the product, the identity element for a product is 1, right? So you would have to have 1, right? For x can't be 0. Or at least that's the rule here. X is not 0. All right. If you have x with an exponent that is negative, then that is the same as the reciprocal. You would have x as the denominator with the exponent n, right? And since now x is the denominator, x can't be 0, because you can't divide by 0. If you have a fraction for the exponent, let's say you have m over n, well, you have the numerator is going to tell you how many times you are going to multiply x with itself, but then n is going to ask how many times, or sorry, what's the number, so that you multiply n amount of times. That will give you x exponent m. Okay, that's a big mouthful, but essentially it's asking for the nth root of x to the power of m. That's basically what it is. Okay, you can write it in a different way. You can write it in a different way. You could write nth root of x, and then all of that to the power of m. Okay, x still can't be 0. All right. Those are the first 4 laws. Well, what if you had to combine a couple of exponents, right? What if you had something like this, right? Combining. Okay, let's say you had x with an exponent, and you have x again with a different exponent, and you're finding the product of those two. Well, if you extend them, you're going to have ax's first, whatever that number is, multiplied by bx's. All right, well, how many x's is that? Well, that's just a plus b x's. So you would end up adding the exponents. All right, a quick example could be x squared times x cubed. If you extend that, you have 2 x's first, then you have 3 x's. Well, in total, you have 5 x's. So that's going to be x to the power of 5, which is the same as adding 2 and 3. A second law could be if you are finding the quotient. Similar idea, if you extend the numerator and the denominator, you're going to have numbers that will cancel out with each other. And you could end up with x's only in the numerator or x's only in the denominator. Okay? Once that happens, you're essentially subtracting the exponents. So that is going to be equal to the numerator minus the exponent of the denominator. Sorry, the exponent of the numerator minus the exponent of the denominator. Okay, if you have x squared over x cubed, okay, you have 2x's at the top, you have 3 at the bottom, okay, and now you can get rid of these two and these two. These are going to cancel out with each other. You're left with 1 in the numerator and x in the denominator, 1 over x. Okay, now this law, number 3, is going to tell you that this can be written as x to the power of minus 1. And if you do 2 minus 3, you get minus 1. Therefore, whenever you have a quotient of exponents with the same base, all you have to do is subtract the exponents. All right. Now, what if you have an exponent within an exponent? What does that look like? Okay, well, if you have, let's say, x exponent a in brackets, and then on the outside you have b. Okay, think about the extension. You would have a x's first, and then you would multiply a x's with itself b number of times. All right. Well, that just means you are doing a number of x's b times. That's straight up multiplication. So you would do the same as a times b for the exponent of x. You can switch the two as well. So you could have x to the power of b times a, and that's exactly 2x to the power of b and then to the power of a. So if you switch the exponents, you get exactly the same. All right. Now the last couple of laws is on distribution. All right. If you have x, y to the power of a, you're going to have a x's and a y's if you extend it out. All right. Well, if you have a x's and a y's individually, you can write the exponents as such. X to the power of a times y to the power of a. And the restrictions for x and y are that x is greater than or equal to 0, just like y. An example could be, let's say, x, y to the power of 2. Okay, well, you have xy times xy. Well, you have 2 x's and you have 2 y's. So you could do x times y. That's x squared and y squared. All right, the last rule for today, that's going to be x over y and the exponent on the outside. Here you have a product of two numbers. Here you have a quotient. And it's exactly the same thing as beforehand. You're going to distribute that exponent to the numerator and the denominator. So you end up with x to the power of a and y to the power of a. For x is greater than or equal to 0, y cannot be 0, so it only has to be greater than 0. All right, an example could be x and y to the power of 2. All right, so you have x over y times x over y. That's the term you're multiplying with itself. That's the base. Well, you have 2 x's for the numerator, so you have x squared over y squared, because you also have 2 y's in the denominator.